Guys, let's get started. I will be reviewing this information over here on the left, and I will be doing it right here in the command window. You can see this is my command window. I just undocked it, and that's where we're going to be staying today. Maybe I'll open an editor. I don't know. We'll find out. Cover relational operators less than, greater than, less than, equal to, greater than, equal to, and not equal to. This is the not equal to symbol. It is the tilde. That's what it's called. It's this one right here. So let's create a matrix first. X is equal from 1 to 5, from 6 through 10, and from 11 through 15. Before we start using find and any, let's just see what x is greater than 20. See what that returns. I'm sorry, less than 20. This shows me that all the values in here are less than 20. And if you see over here, 1 is true, 0 is false. So we have a bunch of 1s. That means that this condition right here is true for all of these. Well, let's find where x is less than 20. And right here, they show you all the positions. Now here he says all locations. I don't like saying location. I like calling these positions. Because if you see, this is position 1, 2, 3, 4, and so forth. Well, let's look back at x and let's change the 6 to something larger than 20. It's equal to 24. Why not? Now if we run that same command, it should give us everything right here except for 2. Where am I? There we go. And skip the 2. So it's calling it by position number. This is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. It's good that we know how to count by positions, guys. It's imperative that we know that. That is the find. And you can use any of these relational operators. Let's find where x is not equal to 3. Now what do we predict here? We predict that it's going to be everything but position 7, right? You see, it goes 5, 6, no 7. Let's look at this one right here. This finds all the values. Let's see why that's true. I'm sorry, I just paused it. Let's get back. I was talking about this right here. Why is this true? Let's break it down step by step. First, let's do where x is greater than 10. It's going to have zeros and ones. X is greater than 10 from here through here. This is position 2, position 3, 6, 9, 12, 15. So that's where it's true. So find where x is greater than 10 will produce 2, 3, 6, 9, 12, and 15. That's what we just said right here. You see that it's just showing us the locations of them now. And remember, if I want to pull out something by its position, I could say x of 2, just to see what x of 2 looks like. X of 2 is 24. I can also do that for a matrix. It'd be x, let me see what x of 2, 3, 4, and 5 look like. Remember, this is by position only. That's 24, 11, 2, and 7. So when I say x of find of x is greater than 10, what I'm really doing is I'm saying this line, but instead of 2, 3, 4, and 5, I'm plugging in 2, 3, 6, 9, 12, and 15. and it gives me the values that are greater than 10, which is 24 and then 11 through 15, because we've changed the second position to 24 from 6. Let's CLC, see what x is equal to again, and let's go on to the next step. Any will return 1 if any are true, and 0 if none are true. So any x is greater than 10. 1, 1, 1, 1, 1. Why are there 5 ones? Pause it for a second and think, why are there 5 ones? There's a reason why. Well, let me tell you. The reason why there's 5 is the any function searches down the columns. Searches down the columns. So let's change one of these columns. Any x greater than 10. Let's change this one. X of 6 is equal to 3. Why not? Now let's run any again. We should have 1, 0. This will change to 0. 1, 1, 1. 1, 0, 1, 1, 1. It's going down the columns, the any function. And let's keep on going. Remember, any can use any rational operators. These operators right here, whichever ones you want to do. Any x equal to 11. And it says, yeah, you got an x equal to 11 in the first column. Well, thank you. That's good to know. I'm glad I know that. Let's keep on going. We just did the any function, and let's get into if statements. Now, let's open up an editor. Let me just dock this so you guys see what I'm doing. I'm working out my command window, and here I'm going to open up an editor, and I'm going to undock that editor, and now I'm going to show you the if statement. So here's the typical structure of an if. It's going to say if comparison, and you're going to have a bunch of statements, and then you're going to end it. That is your typical if statement, and that is exactly how we're going to do it forever and ever. If you could just know it starts with F and it ends with end, that's true forever. And let's do these simple ones. So let's let me put some matrix here. X is from 1 to 5 and from 6 to 10 and from 11 through 15. And then we have some if comparison, and we'll use Peralta's. So if x is greater than -1, I'm sorry, less than -1, display x. Now, what do you guys think is going to happen here? Well, you guys go ahead and see what happens. Is x less than -1? We're going to name this example 1. And I'm going to dock it, and I'm going to CLC clear here. Should have done that at the top of my M file. I'm going to run it. What do you guys think is going to happen when I run this? If x is less than -1, if this statement right here is true, remember, let me give you some hints. Control C, Control V, Enter, CLC. I'm going to undock that, and I just want to show you this really quick. If x is less than -1, remember, we have zeros everywhere. meaning that there isn't one that's being passed when I run this. What's going to happen? Let's see what happens. Run. Well, that's because I didn't suppress this. That was not supposed to happen. Let me just put CLC clear. Close all. Why not? I'm running it, and nothing is happening. I'll even do it this way. Run example 1, and nothing happens. That's because everything that's being passed to it is a 0, meaning that if this is a 0, this isn't going to proceed to anything. It's an if statement. If this is true, do whatever statements you have. Now, sometimes we want to say, if this is true, these statements. However, if it's false, we just say else, we display it's false. We could say if statement is false. And then we can run. You can see here that I ran and said if statement is false. Alright, I shouldn't say the if statement's false. Should have said this comparison right here is sending the if statement to 0. Meaning this is 0. If it was a 1, it would display this. However, it's going to display this. Let's do a scenario where it's not going to be 0. Let's say, is x greater than 14? If it is, display it is greater than 14. Else, display the if statement is false. So, come over here and we can run it and undock, and it still says the if statement is false. Well, mark. Let's look at what x is. It said, is x greater than 14? Well, it has to be true for every single value in there, not just one, for all of them. For all of them. That's important. Not just for 50% of them. I could say, is x greater than 2? And since we have just one 0, you're only as strong as your weakest link. Is x greater than 2? It will still just say the if statement is false. Let me show you that right now. I could clear this really quick. I didn't do anything, still see. And let me run this. And you can see here, the if statement is false. It's still false. And that's because my example here, let me show you what x is x greater than 2. We still have 2 zeros. I'm sorry, 2 zeros. Well, let me show you a position where you would have the if statement send a 1 right here. Remember, this condition right here is only sending a 1 or a 0. Sometimes it's sending multiple 1s, sometimes it's sending multiple 0s. But what's important is, when it's 0, no matter how many zeros there are, if it's 0, it's definitely displaying a false. 1 0 can throw you down to the false. As long as it's throwing a 1, or everything that it's sending out is a 1, it's going to say whatever statement you put here. Now, it doesn't necessarily have to be a display statement, and later we'll see that it usually is not. What we usually do is calculations, but just for simplicity, I'm showing you the difference between the 1s and the 0s. I should comment this. This is for the 1s. This is for the 0s. Maybe you guys can't see that. And that's all we've done. I encourage you guys to pause this video and play with it yourself. Play with the M file yourself and manipulate this value. We don't necessarily have to have it less greater than. We could say it's equal to 100 or 10. We could use all the rational operators. I'm sorry, it's late. We could use all the relational operators. Let's keep on going. Oh, these are the if statements. I think I covered it. Display x of find of x. We covered that. Display false. We covered that. Let's get into some easier if statements. I'm just going to start winging it. I don't know why I want to wing it, but it feels like it's a good idea. And we'll get into some cool stuff. So let's have a CLC clear, close all, and let's open up a new editor. Let's close this one out. I'm sure I'll save the changes. And let's set up another if statement. If, remember, comparison statement end. Remember that this is our initial layout, and so we'll have an initial value of x equal to 5. No, we'll have it 1 through 5. 1 through 5. And we can say if x. No, let's just use one number here. Let's just use 5. If x is equal to 5, we could say we would like y to be equal to 2 times x plus 3. I have no idea. And if it's not equal to 5, I want it to display this value is not equal to 5. And instead of this, let's put an input right here. X is equal to input, let's say, enter a value. Right. Just enter a value. Let's not make it crazy. Enter a value. I like to put a colon, 2 spaces. And that is our new M file that we just made, and I'm going to name it example 2. So for example 2, it says enter a value. Well, I want to enter the value 5. X is equal to 5, y is equal to 13. Great. Great. That's perfect. Let me rerun that again. I should put CLC clear up again. It's appropriate. And I'll rerun this. Control C on it. There we go. Control C on it. Okay. And clear CLC. I'm sorry. Okay. Now let's do it, guys. Let's run it, and it says enter a value, Mark. And I say no problem. I will enter my value, and I think the right value is 10, because this value is not equal to 5. I'm going to say, well, you didn't tell me to enter the value 5. So I think it should say enter the value 5. And instead of saying this value is not equal to 5, I'm going to say something mean like, read the instructions. Now, no, let's not say that. You can say something even worse. And that's some bad 4-letter word at the, oh, that's 5-letter. Oh. And that's some bad 4-letter word at the end. And you get the picture, and we run it. It says enter the value 5. I'm going to be like, well, I like the value 19. And then it says, well, because I messed up. I'm sorry. I will rerun it and enter the value 5, where y is now equal to 13. And you guys are saying, Mark, what does that have anything to do? Why is that? What am I ever going to do with this? Well, That is a good question, and I think that if we go to the back of our chapter, and we are in chapter 8, we could work with some basic if statements to get us through the day. I'm currently turning the pages, but I should put it up on the computer screen so you guys can see. Hold on one second. Alright guys, so we're going to be doing this example right here. It's for the if statement, and this is the PDF of the 3rd edition for Latin. Let me just show you. MATLAB for Engineers, Hollymore, 3rd edition. The book that we have in class is the 4th edition. It's the exact same thing. The book that I'm looking at here on my table is it's the exact same thing. Except for my first if statement, this number right here says 8.11. So I guess you guys you gotta deal with it. Well, I gotta deal with it. If you have the 4th edition, we're on page 307 also. And let's do it. Create a program. Let's pause the video really quick. Let's read what it's asking us to do, and then we'll go forward. Alright, so we're going to see if the person has a fever. That's on the agenda today. While I'm working in a clean environment. And let's get started. You know what? Let me show you a different way to do that. I will instead of saying edit, I'll say edit, and then I'm gonna say problem 8_9 for no reason. And I will say yes, and you will see that it's already saved for me under the name P8_9, problem 8.9. Create a program that prompts the user to enter a scalar value of temperature. So we're going to say x is equal to input your temp. Let me undock this for you. Input your temp and colon 2 spaces. That's just what I like to do. And if the temperature is greater than 98.6, so I'm going to say if statement x is greater than 98.6. Send a message to the command window telling the user he or she has a fever. Display, you have a fever. And then I am going to end my if statement. And then I'm going to dock this. And I think it should be a good idea if I just put CLC clear here. CLC clear, close up. Space right. And let's run it. See what happens. Your temp. What is my temperature? Let me pause the video so I can take my temperature. And I took my temperature and it said 98.9. Uh-oh. It says you have a fever. Well, I did feel a little clammy today. That is true. That was a nice little intro to it. Let's move on to problem 8.10 together. And I will pause this video. I think you guys should do the same. Let's read over the instructions and I will get right back to it. Everybody pause it. Ready, set, go. Ah, that is some trickery right there. But I like where their head's at. Let's exit this. And let's clear this. Just because I like to, I know that's not real. And then say edit. Problem 8.10. Let's see what's going on. Yes, I would like that. Let's start off CLC clear and close all. And guys, I plan on just going through all the way to switch case. I'm probably going to do all of these. So if you want to fast forward to see 8.11 or 8.12, 13, 14, you guys can go ahead. If you want to stop watching, and your stand also. But this is good practice, and I hope everybody is following along. Did I already pause? I did pause the video, but I don't remember what I read. Create a program that first prompts the user to enter a value x. X is equal to input, enter a value for, and I should undock this so you guys can see what's going on, for x, colon, 2 spaces. Well, I should suppress that because I want to see. Then prompt the user to enter a value for y. Input. Now enter a value for y. 2 spaces. That is the first part. I am going to go to the second part now. And it was saying if x, so let's use an if statement. If x is greater than y, if x is greater than y, send a message to the command window. I'm going to say display. Send a message to the command window telling the user that x is greater than y. X is x is greater than y. If x is less than or equal to what? Oops. Else, because what if something else happens? If x is less than or equal to y, send a message to the command window saying that y is equal to, greater than or equal to x. And I need single quotes on that also. And you don't really have to do this. You shouldn't. But I like suppressing stuff. It's still going to display either way. And then I'm going to dock this for us, and I'm going to come over here and run it. And let's pick 2 random values, 6 and, let me undock this so that you guys can see what's going on, 6 and 10. We're going to say y is greater than or equal to x. And that is true, because 10 is greater than or equal to 6. I like that. That was a let's run it one more time. I just want to say p underscore 10. Enter a value for x. Let's say 4 and negative 3. You can see that x is greater than y because 4 is greater than negative 3. So some true statements here. I like that. Let's keep on going. Clear, and I could close this. CLC that, and I could say edit, and let's get ready for p underscore 11. That's what we're getting to. And yes, I would like to do that. And let me undock it, and let's get started. The inverse sine, a sine, and inverse cosine, a cosine, functions are valid only for inputs between -1 and +1, because both the sine and the cosine have values only between -1 and +1. It's a true statement. Matlab interprets the result of a sine and a cosine for a value outside of the range as a complex number. For example, we might have a cosine of -2 as 3.1416 and then -1.317 imaginary, which is a questionable mathematical result. Okay. Create a function called myAsine that accepts a single value of x and checks to see if it is between -1 and +1. If x is outside of the range, send an error message to the screen. If it is inside the allowable range, return the value of a sine. Oh man, that was brutal. Just that last sentence was awful. Let's pause it, reread it. I'm gonna pause it. I'm gonna make sure that I can do this first before I teach it, and then we're going to get to it. So for this, we're going to use the AND operator. Let's go through it together, and I'll show you where we're going through it. So the inverse sine or inverse cosine functions are valid only for inputs between -1 and 1 because both sine and cosine have values. Interprets the value a cosine cosine, which is questionable. Let's pause it. Everybody read it. So what we're first going to do we have to create a function. Create a function called myASign. So the first thing that we do with the function, let me undock this so everybody can see it. First thing that we're going to do with any function is we're going to say function. We're going to have some input, we're going to set it equal to some name, and then you remember output, input, this space right here is reserved for the name. And they want me to name it my underscore, that's not where my name goes, my underscore assign. This accepts a single value x and checks to see if it is between -1 and 1. Okay, perfect. Single value of x. And it's going to return, if x is outside the range, send an error message to the screen. If it's inside the allowable range, return the value of assign. So it's going to return a value, and we're just going to call it as. No, let's call it a underscore sign. So here's where we're going to use the and. We're going to say if x is less than or equal to 1, so because I want the maximum it could be is 1. I want to make sure that it's under 1 for sure. Is 1. Now here's the and sign. And x is greater than or equal to -1. Now check this out, guys. This is the important part. Usually we don't have to use parentheses. Here we do, because it's not just one. I'm going to use a single and, saying that I should use a double. What that means is when it's a double and, it's just going to check this one. It's going to check this one first, and then it's going to check this one. When it's a single and, it's going to check both of them. They're saying it might be a little faster to use double. I'm in here saying, well, I don't mind. I could do a single. So here we have an and it's saying not just one or the other. That's called an or. For or, we're going to use a straight line. Mark, where did you get that straight line from? Look at your computer. You see shift. Above shift you see enter, and above enter you see backslash. We use that backslash for backslash n for line feed in fprintf or printf. C in Matlab. Oh my gosh. Well, if you press shift and you hit that backslash, it now becomes a straight line. And that's called or. Here we're going to say and. I don't know if I can put and right there. So I'm going to put an ampersand. You know, I should try it really quick. No, I'm not going to. If x is less than 1 and greater than -1, I want it to do the arc sign. A sign is equal to a sign of x. And if it's not, I want it to send an error message. Now you see end ends my if statement, and return ends my function. The end can also end my function as well. That's why we wanted you guys to use return for all the functions. For all functions, use return instead of end. That way you don't get confused with the if statements and the while loops and the for loops. You're good to go right off the bat. So let's run this and let's save it as my sign, and let's see if it works. My sign of 4, and when it's 4, we're predicting that it should be an error. It's correct. When it's less than 4, we predict that it will give us a value, a sign, which default variable is just going to be a and s, right? Well, to be honest, I don't know any. I don't know what the a sign of 0.5 is. But if I go over here and I change it to degrees, and I run it, at least I can know if I'm working. Because I know that the arc sign of 1 in degrees is 90. Which is true. The arc sign of -1 in degrees is, well, whoa, let's think about this. 190 plus 180 is 270. or negative 90 degrees. And that's true. That's not wrong. Everybody knows that 360 minus 90 is 270. I was right. I just want to stress that. Just kidding. All right, that was a fun project. Let's go on to problem 8.12. And I will close this down, and we'll never have to look at it again. And well, we will have to. I don't know if we'll look at it. Create a program that prompts the user to enter scalar value for the outside air temperature. All right. Well, we have to prompt the user. Let's say edit. Let's Control-Shift-U undocks it. I didn't tell anybody that till just now. Control-Shift-U undocks it. To redock, it's Control-Shift-D. Control-Shift-U undocks. Okay. Create a program that prompts the user to enter a scale. I'm just going to skip it. Value for the outside air temperature. So let's go out temp is equal to input the value for outside air temp, colon, 2 spaces, and let's press that. You know, I don't like that you guys can't see all of that. I'm just going to say outside air temp. That way you guys can see everything. If the temperature is equal to or above 80 degrees, so if out temp, where am I? Oh my god, I lost my spot. If the temperature is equal to or above 80, it's greater than or equal to 80 degrees. Send a message to the command window for display. What message am I going to say? Telling the user to wear shorts. Yeah, wear shorts. If the temperature is between 60 and 80, send a message to the command window telling the user that it is a beautiful day. If the temperature is equal to or below 60, send a message to the command window telling the user to wear a jacket or a coat. Okay, well that sounds good. Let me pause this really quick because there's 2 ways to do this method, and let me make sure that you have to learn this way. Hold on. You do have to learn both ways, but let me just, I will do it both ways. We're going to end it right there, and we can just start a new if statement. If the out temperature is greater than or equal to 80, display wear shorts. If out temp, I should just copy and paste this. I'm going to be doing it a few times. Control V. If out temp, no, that was silly. So here we're saying if the temperature is between 80 and 60, send a message to the command window. So if out temp is greater than 60 and sign out temp is less than 80. It's perfect. Display, now what does it want to say? It's a beautiful day. It's a beautiful day. Thank you, Jim Carrey. And if the temperature is equal to or below 60, if, I should just say Control V here, if out temp is equal to or below 60, display wear a coat. End. That's not how to spell end. End. Perfect. And let's test it. And this was problem 8.12. I can't save this, so p_12. And I want to blow this up. So Control Shift undock. And I don't like that it's just going right into it. I wanted to call it on my terms. I'm calling it p_12 outside air temp. Well, I don't know the temperature outside right now, but I think it's about 57. And it's telling me I should wear a coat. And let's do it again. The outside air temp. And let's say today is a hot day. Say it's 80. Wear shorts. Nice. Let's say it's 100. I can't say that. Say it's 100. Still supposed to wear shorts. Okay. And let's say that it is 65. Now it's supposed to say it's a beautiful day. It's a beautiful day. Perfect. It did exactly what I wanted it to. Let's Control Shift D and let's open 8 underscore, what are we on, 12? I thought we were on 12. Oh, I have to enter P right there. Let's open it and let me show you the other way to do it. So this is called an else if structure. And let me just open this up. And the way that it's set up is if comparison statement, else if comparison statement, else if comparison statement. Yeah, I see that I left an M off, and I might be spelling things wrong all the time. I'm not sure. I'm not going to change it. Else statement end. What's important here is that we always end an else if statement with the term else. We have to end it with the term else. We can't end it with an else if. Now let me show you how we could clean this. No, I don't want it. You guys might want to write that down or save it in your notes somewhere. You know what? I'll save this. I will save it. I'm sorry. Sorry, I didn't save it. Save as else if. No, I can't rename it. That is silly. Else underscore it. No. And let's go here. So let's use else if. If the temperature outside is greater than or equal to 80, display wear shorts. Then we say end. But if we backspace this and switch these two letters to say else if the temperature is between 60 and 80, display it's a beautiful day. And we take this right here, double space, change the END to LSE. Now it says else if. Out temp is equal to display coat, but we don't want to break the rule. We want to say else out temperature, and let's run it. Now I think there may be a problem here. There's not a problem yet. Let's say 60. Wear a coat. No, it's still working perfect. That's good. I thought that was going to be a problem. Well, let me show you why I thought there was going to be a problem. We actually don't need this line of code right here. Let me show you why. And we actually don't need these two comparisons right here. We could just say if out is greater than 60. And the reason for that is if the temperature is greater than 80, we're covered. Now, if this is false, it's going to jump directly to this line, and it's going to say, is this statement true? If it is true, it's going to say it's a beautiful day, and it's not even going to worry about this part. However, if this is false, it's going to jump down to this line. Now, since we only have three options, either it's greater than 80, it's between 80 and 60, or it's less than 60, we actually don't need this part right here, because if it made it down this far through the line, it has to be less than 60. So that part could be removed. You guys understand that if it's less than 80, it's skipping down to this line, right? So let's say we input 77. This first part is false. It's not going to display this. It's going to skip down. Is out temperature greater than 60? Well, out temperature is 77. 77 is greater than 60, and we are going to display it's a beautiful day, and we're not going to worry about this part because this part's satisfied. We're only looking for one true. One truth. Only one person has to be telling the truth here, and we are happy with that. So let's see how this runs. And actually, I want to run it on my terms. My terms. So I'm calling the M file by saying P8_12. And it's asking for the outside temp, and I just explained the temp 77, and it's going to say it's a beautiful day. You're saying, Mark, I don't believe you with any value less than 60. I understand that. But let me show you. 55. I have to wear a coat. Control-Shift-D. And then I'm going to open P12. P8. P8_12. And I spelled open wrong. Well, the reason that worked is because 55 doesn't satisfy this, and 55 definitely doesn't satisfy that. And so, no matter what, any value less than 60, it's going to say wear a coat. That's beautiful. Well, let's close this. I'm happy with it. It says CLC clear. CLC again. Let's close all. Let's CLC again. I don't know if you could tell that I'm CLCing clear a lot. Just for no reason. I don't know. It feels good to have a nice clean workspace. Let's go on to, we'll get up to here, 813. We might go to 814. We're definitely not going to switch case today. This video is long already. Let me see. It's 47 minutes long. Oh, wow. Okay. Now I have to re-watch it to make sure that it's able to be seen by other people. And hopefully it is, because I went straight through it. Suppose the following matrix represents the number of saws ordered from your company each month over the last year. So I imagine that there's 12 little spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. All the numbers should be 0 or positive. Okay. Use an if statement to check whether any of the values in the matrix are invalid. Evaluate the whole matrix at once in a single if statement. Send the message all valid or invalid number found to the screen depending on the results of your analysis. Change the SAWS matrix to include at least one negative number and check your program to make sure that it works for both cases. Okay, so we are going to say SAWS. Did it say I had to input them? And we're just going to hard code it. These are what they wanted. 4, 5, 3, 7, 5, 3, 10, 12, 8, 7, and 4. Well, let's check that I have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I needed 12. What number am I missing? 1, 4, 5. There's a 5 right there, Mark. Silly guy. Perfect. Then do an if statement. Check whether any of the values in the matrix are invalid. And they're only going to be valid if they're not greater than 0. So SAWS, when SAWS is greater than or equal to 0, display all valid. Else display invalid. Invalid. Let it ride, guys. Just let it ride. I was talking to myself right there, and I couldn't let it ride. And, alright, let's hope something happens. What problem is this? P13. Problem 8_13. Save. And doc. And it says that they are all valid right now. But then on part B it says check the SAWS matrix to include at least one negative number. So we're going to say this is -4 now. We're going to save it. We're going to clear it. We're going to run it again. And check your program to make sure that it works for both cases. Now it is invalid. Now let's get to talking why this is true. Let's undock this and let's see what SAWS is. That is SAWS right now. And if we say SAWS is greater than or equal to 0, we'll see that we have 1 0 right here. And remember, for an if statement, if there is just 1 0, it drags us all down. We are wrong no matter what because one guy lied. You're only as strong as your weakest link. So for the if statement to be true, and referring to this if statement right here, we need ones to come in. It could be just 1, 1, or it could be a matrix of ones. We need all the numbers coming in to be a 1. We need this to be an absolute 1 no matter what. Otherwise it's going to be a 0 and displays invalid. What do I mean by 1? Some of you guys may be asking that. Well guys, this is a conditional statement. I hope I went over this. And no matter what, it's going to send us 0s and 1s. You know, I didn't say that. I did not tell you that. That was poor teaching on my part. Undock. Guys, no matter what, these conditional statements are going to give you 0s and 1s. 0, 0, 0. We have 110 in there, thank God. No matter what, 0s and 1s. Forever and ever. We have less than 10. We have showed you all your 1s and 0s. We have not equal to 100. That's not 100. That's 100. You'll see that they're all 1s. None of them are equal to 100. So you see that the relational operators, I think I called them conditional, I've done that before. They give you 0s and 1s. That's what's important. Now let's do 8:14 and then for real, I think I'm done. I don't have anything left to do after that. So let's dock this, and I could close this, and I could clear everything. You'll see. Let's get started on a fresh sheet. Most large companies encourage employees to save by matching their contributions to a 401k plan. The government limits how much you can save in these plans because they shelter income from taxes until the money is withdrawn during your retirement. The amount you can save is tied to your income, as is the amount your employer can contribute. The government will allow you to save additional amounts without the tax benefit. These plans change from year to year, so the example is just made up. What if? Thank you. I thought this was a real example. I wasn't sure if it was made up or not. I read it, and I honestly I don't know what it said. That's bad. Suppose the quality widget company, okay, has a savings plan described in your table. Create a function that finds the total yearly contribution to your savings plan based on your salary and your percentage you contribute. Remember, the total contribution consists of the employee contribution and the company contribution. Guys, this is actually Peralta's example. I know it's Peralta's example because I taught it last semester for Peralta, and he likes to do this example. So I'm gonna let Peralta do this one in class. This one is brutal. I'm happy I'm dodging it. However, if he does not do this example, I will be more than happy to put a little link to the page, and I will do this example for you online so everybody can review it. Alright guys, that is it for the if statement. I hope all of these examples were helpful, and I assure you, you will see this one no matter what. I might save it for an in-class lecture. But I will be seeing you guys soon, I guess. I don't know. I'll see you guys though. Okay, have a good one. Goodbye.